Good afternoon, my YouTube viewers. It's Crystal here. In this video, what we're going to do is we're going to talk about the stem and leaf plot. And the stem and leaf plot is a specific statistical visualization that a lot of people end up doing by hand. But the great thing about R is R has an inbuilt function to allow you to create a stem and leaf plot, which is completely different from Python. Python does not have any functions to help you create a stem and leaf plot. You would have to import a library in order to do that. So if you need to make a stem and leaf plot, then R is probably a good programming language to do it. So a stem and leaf plot, in this example here, we're going to have a stem has 1, 2, 3, 4. So that's 10, 20, 30, and 40. So the numbers on the left are you divide the numbers by 10. So instead of 1, 2, 3, 4, it would really be 10, 20, 30, 40. And it represents tens. And the leaves represent ones. So it's a text-based way to visualize the distribution of numeric data, similar in spirit to a histogram, but preserving the actual data values. And so what we're going to do is we're going to create a stem and leaf plot by the value of x. So x becomes c, that's you're creating a vector of brackets 12, 15, 16, 21, 24, 29, 30, 31, 32, 33, 45, 46, and 49. And then you enter the code stem brackets x, and that gives you a stem and leaf plot. So the decimal point is 1 digit to the right of the solid line. So 1 equals 10, and so 10 is 2, 5, 6 to represent 12, 15, and 16. And 2 equals 20, and you get 1.9, and it represents 21, 24, 29. 3 is 30, and it represents 30, 31, 32, 33. And 4 represents 40, and it gives you 45, 46, and 49. So just to show you how to do this, we're going to just do it again. So we'll say 5, 6, 7, and then we'll say 10, and we'll say 23, 24, 25, and then we'll say 35, 36, 37, 38, and then we'll say 41, 42, 43, 3, and then we'll say 56, 57, and then we'll say 61. And this is just stuff that I'm just making up off the top of my head. And we run it, and it says error. Let's try it again. So we got it to work. We had 0. So for 5, 6, 7, and 10 is your 0. And then we had 2. We didn't have a 2. So let's try it again. Let's say 10 and 11. So again, it says 0, 2, 4, 6. So it's not giving you a 0, 1, 2, 3, 4, 5, 6. It's saying 0, 2, 4, 6. But so it gives you 5, 6, 7, 10, and 11 for 0. And then for 20, it gives you 23, 24, 25, 35, 36, 37, 38. And then for 40, it gives you 41, 42, 43, and 56, 57. And for 60, it gives you 1. Because what I wanted to do is I just wanted to make a different type of data to show you how it works. But obviously, I think that the Pareto chart in R, it will only give you 4 rows of data. And then if you have more than 4 rows of data, then it just adds them. So let's try this again. Let's say Z. Z. And then so we'll say 0, 1, 2, 3. So we'll get rid of the 4s, 5, and 6 because it's only going to give you 4 rows of data. See what it does. So it only gives you 4 rows of data. For 0, it gives you 5, 6, 7. For 1, it gives you 0 and 1. For 2, it gives you 3, 4, 5. And for 3, it gives you 5, 6, 7, 8. So let's take out one of the 11s. So there you can see that's a little bit different, just to give you an idea of how to make a Pareto chart. So if you need to make a Pareto chart, it's probably a good idea to use R. Then try to find out the correct library to use in Python. And then that would just be my suggestion. So this concludes the video on the Pareto chart. I hope that you like it. And the next video is going to be on some different visualization that it's not going to be a visualization that you're normally going to see. And that's why I decided to include it in this series of videos.